All right. Good morning, everyone. Thank you for being here today. My name is Rachel More-Hla, and I'll be sharing details of a project I've been working on over the past year, which used Esri applications for an assessment of culvert conditions and their impact on critical species. The title of my project is Measuring Multi-Species Habitat Connectivity and Infrastructure Assessment in a GIS Web Application Workflow. Across the country, infrastructure is aging and becoming a problem. Roads and stream crossings in remote locations of our national forests are in need of maintenance and repair. Having a list of priorities makes implementing maintenance more feasible, especially under limited budgets. And conducting an inventory can aid in prioritizing future work. Today, I'll be telling you more about the need for the project, how culverts to be surveyed were determined, and the methods I used to build a field survey. At the end, I'll share some of the results and conclusions of the project. The 7 species shown here rely on aquatic or riparian habitats and occupy the project area in the Santa Fe National Forest. The species include the New Mexico state fish, 2 endangered species, and 4 species of greatest conservation need. The SGCN and endangered species are declining in population numbers due to habitat loss, among other reasons. This project addresses the problem of aging infrastructure, which is not uncommon across the United States or in other national forests. One of the main drivers of the project was the New Mexico State Wildlife Action Plan, which calls out man-made structures as impediments to wildlife movement. The project was proposed by the New Mexico Department of Game and Fish, asking to develop a spatially explicit database of stream crossings that are creating barriers to wildlife movement and where structural improvements can benefit SGCN on public lands. My work on this project addresses the need for a database and digital data collection methods that incorporate GIS-based applications. Most efforts across the country are doing similar work, but using paper data sheets still. I started by compiling all the necessary spatial data into ARCGIS Online. From there, I created a targeted culverts layer containing all the other data in relation to each culvert. The project area was within the Jemez district of Santa Fe National Forest in northern New Mexico. Streams in the area were narrowed down to only those listed as perennial waters overlapped with habitat area of at least 3 of the key wildlife species. Culverts and bridges were narrowed down to those within a quarter mile of those 6 remaining streams that you can see here on the project map. The culvert inventory was based on national methods established in 2005 by Clark and et al. Small adaptations were made to the protocol to collect data on structure details, including the length, shape, condition, and type of the culvert, measurements of the inlet, outlet, and surrounding channel above and below the culvert. Riparian and water quality measurements were taken, including vegetation cover, sediment type, conductivity, dissolved oxygen, and pH. Final habitat scores were weighted calculations based on observation of habitat in relation to each species requirement that was within the area of the culvert. And finally, GPS points and photos of each structure. I developed a project map in ArcGIS Online and configured the settings to be used in auto mode. And in doing that, I also specified small areas of the map to download in ArcGIS Collector, which helped minimize space requirements on mobile devices. The culvert point feature pop-ups in the map were configured with a link to open Survey 123. From Collector, the user is switched automatically to Survey 123 on the mobile device, and culvert attribute data is entered into the respective fields of the Survey 123 form. This helped to decrease data entry errors and typos. The data transfer also confirmed which habitat areas overlapped with culvert being surveyed and the wildlife species conservation status. Those two attributes were both necessary for the final habitat rating calculations. And the screenshot here shows the collector with the map pop-up and the link to the Survey 123 form. I adapted the established paper protocol into a digital form using the desktop application Survey 123 Connect. The XLS form builder and Connect allowed for more customization in comparison to their online version. The Culvert survey form totaled 138 lines for questions and 100 lines for responses. Within the form, I included images and flowcharts providing guidance to the user in the field. I also built in calculations and used if-then functions, and these logic checks provided quality assurance throughout the data collection process and limited user effort in the field. From Connect, I then published the form to Survey 123 to allow for mobile download and offline data collection. And here's a look at the survey on the mobile device and some of the questions there. Once all the field surveys were finished, the next stage of the project was to share the results. And one way I did that was through a story map. Story maps are visually captivating, and I hope that sharing this publicly will garner support for similar projects in the future. I chose the sidecar story map template to display each stream and provide the viewer a map-based tour of the project area. Culverts in each of the maps were symbolized by their structure rating, with green being good, yellow being fair, and red being poor. Pop-ups were configured with the Survey 123 data for each culvert. To configure photos within the pop-up, I added attachment IDs to the attribute table of the Survey 123 results. The attachment ID field was added to an arcade attribute expression to pull the specified culvert attachment from Survey 123. And then that expression was selected in the pop-up media options to show the culvert image. Now we can take a look at some of the results from the field surveys. Of the 99 culverts and bridges surveyed, 9 were not located. They were either buried, removed, washed away, or the GPS data information was incorrect. Structure condition was the first metric that the Forest Service uses to prioritize repair or restoration of a culvert. And the results here show that nearly half of the surveyed culverts were in good condition. In addition to the structure condition, a final habitat rating was given to each structure, and these rating values are calculated based on subform repeats in the survey, but only for the structures that were aquatic. These are the two main metrics the Forest Service will use for the restoration prioritization. This project provided an opportunity to ground truth infrastructure data within Santa Fe National Forest. By identifying priority barriers for future restoration projects, the Forest Service has the data needed to improve connectivity of riparian habitats, which have a considerable role in preserving and protecting wildlife populations. These are friendly Esri apps made field data collection easy to allow for offline data collection and enabled survey crews to work in remote locations. This project showed some of the impressive capabilities of integrating multiple Esri applications into a single project. I'd like to thank all of the partners involved in making this project a success, especially Sean Stone and Tiffany Love Chesum, who were the field leads in collecting all of the survey data. And I'll open it up for questions now.